The frictional coefficient between the athlete's shoes and the road is 0.90. Okay, if the Superman wears these shoes, and then how much minimum time he will take to complete the distance of 50 meter. Okay, so we have to find out that. Now, if Superman is running with these shoes, the maximum frictional force in the right direction, in the direction of motion of this Superman, will be the mu mg force. This is the frictional force that is causing the Superman to move forward. Now the acceleration A is equal to F by m. So we have the acceleration which is mu mg by m. Mu mg by m. So that is equal to mu times g. So we got the acceleration as mu g. Now we have to find out the minimum time. Now when will be the time minimum? When the acceleration is maximum. So when the Superman runs with the maximum acceleration, the time will be minimum. So let's find out that time. So the displacement is 50 meters. So I will use this formula. S is equal to ut plus half at square. Since the initial velocity is 0 and s is 50, so this is half into mu g. Mu is 0.9 into g. G is 10 into t square. So this is 50 is equal to 9 by 2 into t square. So this is 100 by 9 is equal to t square. So t is coming out to be 10 by 3 seconds. So 10 by 3 seconds is the minimum time in which the Superman will complete 50 meter distance. Now the next question is that suppose he takes exactly this minimum time to complete the 50 meter. Okay, so this minimum time he has taken to complete the 50 meter distance. Then what minimum time he will take to stop? Now for minimum time to stop, the acceleration would be simply minus mu g. Okay, because we have to have maximum deceleration. If the Superman has to stop, we have to have maximum deceleration, and maximum deceleration possible is minus mu g, right? So we have to have this. Now how will you find the time? Let's say the velocity after covering first 50 meter is v. Okay, so v is equal to u plus at, right? This is the final velocity. So v is equal to u is 0 plus mu g. Mu g is 9. Just we have done this. This is 10 by 3. So this will become 30 meter per second. 30 meter per second. So the velocity is 30 meters per second for first 50 meter, right? So this is the initial velocity for the second part. But why? Because in 50 meter the Superman has to stop, right? So now this will become our initial velocity 30 meter per second for this particular motion, right? So let me write it as u dash. U dash is 30 meter per second. So u dash is nothing but v. Now the acceleration, or rather deceleration, is minus mu g, right? So the final velocity should be 0. 0 is equal to u dash minus mu g into t. So 0 is equal to u dash is 30 minus this is 9 into t. So 9 into t is equal to 30. So t will come out to be 30 by 9. Okay, so that will be 10 by 3 seconds. So exactly the same time, 10 by 3 seconds. Obviously it has to become the same time. So he will take 10 by 3 seconds to accelerate to 30 meter per second, and the minimum time to stop is 10 by 3 seconds.